very hearty good evening to all the participants out here. And today we have grossing 162 participants in the beginning itself. So, Center of Excellence in Safety Engineering and Analytics, IIT Kharagpur welcomes all the participants to this 26th weekend talk of Safety Engineering Management and Analytics. This program is conducted under Azadi Ka Amrit Mahotsav, which commemorates 75 years of India's independence. We start the program with the beautiful shloka, Asato ma sadgamaya, tamaso ma jyotirgamaya, mrityor ma amritam gamaya, which in totality leads us from ignorance to the truth, from darkness to light, and from death to immortality. So I request our dignitaries to be on the dais and to put on their videos. We have Professor J. Maiti, Chairman CoE-SEA, Professor Obi Krishna, convener of the Weekend Talk series, and Professor M. Bhasi, our expert speaker of today's Weekend Talk. So we have a very interesting topic today, using a Swiss cheese model to understand the electrical accidents. So Professor Dr. M. Bhasi is a Director of Inter-University Center of IPR Studies, Chairman Board of Studies in Business Administration in CuSAT. He also serves as Independent Director on the Board of Lakshadweep Development Corporation. His teaching experience at the School of Management Studies, CuSAT, accounts for over 30 years now, and currently as a professor and over 14 years, 8 months. He was the Managing Director of Consumer Fed Kerala during August 1999 to August 2002 on deputation from CuSAT. He has guided 17 PhDs under the faculties of Social Sciences, Engineering and Technology at CuSAT Kerala. He has published 40 international journal papers, 27 national journal papers or book chapters, and 28 conference papers. His publications have received 764 citations and has H index of 9 and I-10 index of 9, according to the Google Scholar. His administrative experience extends from being the Dean and member of Syndicate of Cochin University for 2 terms, Dean member of Syndicate of Kannur University, Dean member of Management Studies, QPOS, Chennai. He has successfully undertaken consulting and training assignments for many public and private sector organizations such as Kochi Refinery, KSFE, Cochin Port Trust, NABARD, and many others. So he has achieved various awards like Best Paper Awards of IIIE National Conventions, Special Appreciation Award from CuSAT, Best Researcher Award from Calicut University. So, sir, we welcome you to this weekend talk, and I request our Chairman CoE-SEA to formally welcome our expert speaker. Thank you, sir.
Thank you. Thank you.
Thank you, Mom. In fact, Professor Bhasi, I cannot express my pleasure to have you today in this particular session as we can talk from the Center of Excellence in Safety Engineering and Analytics under Azadi Ka Amrit Mahotsav. And see, you are so popular that is basically, that impressed me the maximum today. So even at the beginning, just within 5 minutes, we have around 200 speakers. 200 participants. Yeah, they are also speaker in the sense they will be asking some questions at the end. Second thing is that the topic, actually so nice a topic. Particularly, we all talk about Swiss cheese model, and we also say the electrical accident and electrical is an important issue. But linking a practical aspects to a theoretical model like Swiss cheese model, this is really very catchy. And after seeing that title, I was so impressed that I said, no, that such title are very much important for not only for academicians, for all the industry people, because we all are struggling with this electrical accident. Wherever there is a fire, mostly we say that okay, short circuit and electricity problem, something like this. And so I know that you don't require any introduction, although Mom has given some introduction. But one thing I can tell that Professor Bhasi is our alumnus from our department. I think you were probably the batchmate of Professor Mohanty, Vishwajit Mohanty.
Yes.
And you did your MTech, I think, in Industrial Engineering and Operation Research.
IUR. Yes.
IUR. And those days, I am telling you, I must tell to the participant, those days getting IUR in Kharagpur, it was a dream for every engineers who are planning to, engineering student who are planning to go for master degree. And I think it was probably filled before computer science, MS, MTech in computer science. That was the craze on those days. And Professor Vasi is one such achievers, I can tell. So, Professor Vasi, I don't want to extend my introduction because I can talk more than half an hour or 1 hour about you. So we will definitely we are eager to listen to you. And from CoE-SEA side, we all welcome you. And you know that it is a noble venture that basically created by IIT Kharagpur and our present director, Professor V.K. Tiwari. He basically established this particular center in last year. We are 1 year old, and we definitely have to go many miles to come to maybe the world standard, but definitely we will try to achieve it with the help of people like you. Mr. Vasi, please
Thank you.
start your lecture.
Thank you. Will I be given permission to share? Yes, I have got it. Yeah. Thank you. Let me share. Is my slide visible?
Yes, sir. Visible.
Thank you. I'm very grateful to the center for giving me this opportunity and this audience. The work I have done, what I try to do is mix theory and practice. And that is exactly what I have tried to do in this presentation, which is based on a paper we have published analyzing the cause of human electrical accidents using Swiss cheese model. Beena is doing PhD with me, and Dr. Babu, who is the co-guide with me, who supervises this work. Let me just take you through the background, though it is known to you, just to till the soil before you sow the seed. Accidents have been a major concern for a very long time. Though in earlier days, accidents were always attributed to the zone in which it was involved. I repeat, when you study accidents, you just focus on the zone where the accident occurred. Now, accidents are understood to have deeper and wider causes, even covering practices in society and industry. Studies on electrical accidents reported in literature have mostly focused on the causes in the proximity of the accident and have not taken, many of them have not, I say most of them have not taken a wider view of the phenomena leading to the accident. In industrial situations, even the causes of the accident in the proximity of the site and time were not in the control of the people there at that time and place. I repeat, when the accident is taking place, the things which happened there were not within the control of people there. So just by studying things in the proximity, which people in that point of time there could not control, it will be difficult to bring accidents to very level. Decrease of accidents can happen, but eliminating accidents or bringing it like we did in quality management, zero defect, zero accident, bringing it to those levels will be difficult. Because many things that happen there were a result of decisions taken at a different time by different people at different places. This being the case, there is need to manual accidents and bring out the causes at the organization level, working environment and system level, workplace and human issues, all in one module, showing their interrelationship. This is the thought which led us to this work. So we are trying to understand and depict the causes of electrical accident at these multiple levels, not just the causes which occur in the proximity of the accident. A review of literature with this focus. Yes, revealed that first thing is safety is a complex phenomenon, no doubt about it. And the approach which has been used from long back to improve safety, we must know the factors that cause accidents or hazards and try to act on them. Information about safety issues help decision makers, meaning if safety issues are studied and information is generated, it helps in improving safety standards to developing effective management strategies. Identifying and addressing, eliminating threats helps in reducing risk. Then continuous improvement, efficient feedback mechanism in this area helps in improving the system and reducing accident. So the philosophy of PQ and type philosophy here also it applies. You have to continually improve and not just get satisfied with one. There are many theories which explain, you have been used to model. And I saw a recent paper on, which is an excellent paper and has discussed 100 years of accident causation models for 100 years. This is a very good point to start with. Let us look at some of the theories. This is a theory. We have selected certain theories not based on importance, but based on suitability for our thought process. Suitability for our thought process. That is hierarchical arrangement of causation. So here, Heinrich domino theory is one such theory where different dominoes, social environment, then fault of a person, unsafe act resulting in accident, which results in injury. Here it says one of the dominoes falls on the other, it falls on the other, it falls on the other, and so on, and results in injury. There is a cascading effect which happens. So it's just trying to depict this stack of cards which is falling, collapsing, that kind of a thing, domino theory. Then there is this Farrell's human factor theory, again, just spreads out the whole factors there. It looks at overload, capacity, incompatibility, improper activities, resulting in human error, initiating accidents. Accidents happen, outcome is there, and causal chain is there. Focusing on the human factor. There is also model, Peterson's accident-incident model. Accident-incident model causes, subcauses for the unsafe act and unsafe condition. So we divided the whole thing is both unsafe act and unsafe condition are necessary for an accident to occur. Unsafe act, but in a safe condition, will not result in an accident. Unsafe condition, but unsafe act is not there, again accident doesn't happen. So an accident has two parts, both unsafe act and unsafe condition. For an accident to occur, which may cause injury, damage, near miss, and so on. Incident or accident. The system model of accidents considers the whole machine, person, and environment and their interaction as a system. And the model suggests that we need to collect information, weigh the risk, make decision, and then do the task. This is a very broad model. The systems model, all systems model are broader at the broadest levels. Recent Swiss cheese model is what we have used because the hierarchy is made by top level decision makers, managers, designers and planners, line management, and operation maintenance, and the technical faults and conditions. So in the Swiss cheese, like in the cheese, there are holes. In each slice of the cheese, there are holes in some position, random positions. In the next slice, also there will be holes in some random position. And so on in all these cheese slices. If you are using a laser pointer, for example, and pointing through a hole, if in a straight line of that hole, there are holes or there is a hole in the cheese slice next to it and so on, only then, if there are all these holes are aligned only, then the light will reach this destination or the accident. Meaning, there should be a hole is a problem as an issue or an unsafe condition, so to say, or unsafe act. So if there are holes, these holes are aligned only, accident takes place. If one of the cheese does not have holes and is impervious, then accident will not happen. So this is the view of the cheese model. And looking at the models that we saw now, we thought for our purpose, what we are trying to do, cheese model is the best. So that is why we decided to go for the cheese model. There is also, regarding seriousness of the accident injury, is depicted by Heinrich in the pyramid form. This pyramid risk behaviors, 3 lakh risk behaviors, 3,000 near misses, 300 recordable injuries, 30 workday cases, lost workday cases, and 1 fatality. So it's in the form of a pyramid. Numbers as you go up get decreasing in a ratio. So there is in this pyramid form, there are other things depicted, for example, injury prevention pyramid, load management, overload the person gets tired, person is not cautious, strength training. This was with a particular kind of job which involved a lot of physical work. So this kind of an injury prevention pyramid. Triangle of accident prevention is also depicted in the form of a triangle. For example, and this is very evident, at the base is PPE, the personal protective equipment. That can reduce a lot of accidents because it acts at the last point, just before the accident or incidents. That is where it works. And many a times it does prevention, and many a time it reduces the impact of the accident. Not only prevention, but it impacts it impacts the number of accidents very much. So it is lowest on the triangle. Here, administrative and workplace control. So that is at the supervisory level. Better supervision results in the next largest amount of decrease in accidents. Engineering controls are there at the top of the pyramid, which result in making things safer, but their total impact, effectiveness, if you see, as you go up the triangle, effectiveness decreases. And that is why you see, for safety, in most industries, the initial money spent on safety is on PPE, because that is the one which, with some investment, gives the maximum return in form of effectiveness. And then in the closer supervision and resulting in safer work procedures. Investment in engineering controls for safety, if it is not coming with the machine or the equipment that you buy, later in field it is only a later choice. It is not the first choice.
Hello, sir.
Yes.
Actually, sir, you have to again reshare because you have accepted the annotation request. So
I'll have to reshare.
You have to stop the sharing and then you have to again reshare.
Okay. I will not accept the request henceforth.
Yes, sir. Yes, sir. You have
I
to
will
decline.
I will decline. Okay.
Yes, sir.
Okay. Let's stop sharing first.
Little, sometimes voice, little lag is there. Just
I speak a little slowly because that's all I'll be able to do, because this line is good. I generally have no problem with the connectivity, and then because all these are shared facilities, View has given connection to many people, and especially in the evening, many might be chatting or video chatting and using those facilities. So that is why my slide is moving.
yes.
Yes, sir.
Yeah.
Yes, sir.
Okay. Coming to electrical accidents and accident hazards, we all know the major hazards due to electricity are electric shock, fire, and arc flash. That is the trigger. From there, like Professor Maiti was saying, now in modern times, matchstick is not the cause of most of the fires that happen. It is electric fire. Usually a small cave from which the whole thing happens. Electric shock is due to the body getting in contact with electric circuit, or the body becomes a part of a circuit. Severity depends on the path through which the current goes. If it goes through your head, heart, and things like that, there is more problems. Magnitude of the current, exposure time, and the type of skin, wet or dry. In addition to electrical shock hazards, spark from electrical equipment serves as an inflammable, serves to detonate an inflammable or explosive vapor. Hazardous flash occurs due to high energy, regardless of voltage. This happens in switches, panel boards, motor control, metal clad of switchgear, transformer, motor starter, and many faulty equipment. The objectives of the study were to identify the different cheese slices at what will be the levels of aggregation, and what will be the level of aggregation, and in these aggregated levels, what will be the factors which come. Both these had to be found out. And we wanted to find out from the field because those are the people who know this better. To identify the vulnerabilities or basic nature of the cheese and to arrange the cheese slice with holes in a cheese model. To find the relative importance of then not only to find the holes, we wanted to put the size of the hole should be proportional to its importance. Size of the hole should be proportional to its importance. So we should wanted to find out its importance. To study the perception difference on the importance, because we were trying to gather this, we planned to gather this from a survey of people involved. So survey responses are always based on perception. So we wanted to survey different people. We wanted to survey workmen. We wanted to survey supervisors. We wanted to survey people like executive engineers, middle level, and then the top level people. And also have a panel of experts who will give their perception. So the model, experts, management, supervisors, and workmen all these category of people were surveyed. And we wanted to find out. I declined, but then again, this got stuck, I think. This time, I declined the annotation request. I think I should do nothing up with it.
Better you don't touch it.
Because I touched it, I declined it, and then again this got stuck. So I will just reshare it again.
Yeah.
Shobik, but who is sending this?
Actually, sir, some participant usually send.
Why?
That I don't know, sir. They send.
No. All the participants, we have request not to send anything.
Yes, sir. Yes, sir.
If
Because
you have
that
any
is-
queries, anything at the end of the lecture, you please ask. Okay, the presenter know what is to be, which link to be clicked. If required, they will do it. Okay. Okay, Professor Basi, sorry that for the disturbance. Please.
That doesn't matter. Let me see. Because after that, when I start my slide movement, okay, I have stopped sharing, and now I will share once more. For me, it has got stuck. I'm resharing, but then again, my controls are, it's working.
Sir, due to some network issue, it may be delayed.
No, it's working now. It's working.
It's working, yes. So let me to study therefore we try to gather the perception of experts, management, supervisor, workmen, and try to analyze the difference in perception and understand that also. So the design and the methodology used in this study was that we used the Delphi kind of expert survey was conducted to find the cheese slice generator. From literature, we took a large number of slices and the causes also, and gave this to experts, and through multiple rounds in a Delphi experts Delphi exercise, we convert them into slices and the holes in the slices. Holes are the issues pertaining to that level. This thing which was obtained from the expert Delphi exercise with the experts was converted into a questionnaire, and it was distributed among 3 groups: managers, supervisors, and workmen. From assistant executive engineers above were called managers. Supervisors were the direct supervisor and the assistant engineer or the supervisor itself. Workmen were mostly linemen working with Kerala State Electricity Board. All the personnel were from the Electricity Board because we wanted to test it in a common environment. And the perception of their importance of each of the causes were got. They were asked to, in each slice, all the causes were given and what is the importance of that. On a 10-point scale, they were asked to give a grade point to these causes. Inputs, similar inputs are again got from the experts also. The inputs got were analyzed. The slides were work culture of the organization, slice 1, no or poor supervision, working on live wire, lack of good system knowledge, inadequate information, poor maintenance, poor control of work activity, poor documentation and reporting. These were identified as part of culture because in some places, if there is a seniors, others have been working on live wire. And it is a practice in the organization. People who come fresh also tend to follow that. Working environment and system under which there is, because in the system itself, there is a lot of places where arcing is, we have seen in the distribution system, if work is not done properly at all the places where the naked wires are joined, there is electric fire or arcing. Inflammable material kept at places near the transformer, they have dumped waste, things like that. Time of the day when the work is done, weather condition, non-isolation of the system, practice regarding isolation, control of isolation. That was working environment. Workplace issues, unguarded live wire, less mechanical support. For example, on a very, very broken ladder, that person is trying to get up. Less clearance between the equipment of the system, defective equipment, wear or tear, improper procedure, backfeeding. Human factors, non-use of PPE, negligence, removal of wrong fuse or wire or isolator, fatigue, sleepiness, working too fast, working on a metal ladder with less clearance, alcohol consumption, emotion and stress, health problem, and not competent were identified as the holes in the human factors. From the cheese model regarding the first factor, for human factors, the importance given by managers to various were taken, the importance given by supervisors were taken, importance given by workmen were taken, average score, and the importance given by 15 experts. Let us just look at a few of this. Not using PPE provided has been given very high scores, 9 points by the managers, 8.6 by the supervisors, but actually this is regarding the practice by workmen. And workmen, strangely, gives not using PPE is not the issue, major issue. For them, it is getting a score of only 7.9. Whereas experts also say 9 score for that, which means that they are not convinced that not using PPE is a very big cause of accident. So, from the data like this, the difference in perception, if it is analyzed deeply, we know where the problem lies. What is the thing? Who is not understanding, not giving enough importance to, and measures, training, and other exposure measures can be taken to bridge that gap. For example, working on material ladder, these two people have given less, but then managers have given high because there are now very low weight aluminum ladders and old bamboo ladders are very heavy, and these people like to carry this lightweight, and they are working more on that. Alcohol consumption is also there in Kerala, which the managers realize, but the supervisors are not that willing to admit. 7.7 only, and these by the workmen who are involved in this, they say only 7.5. And the experts give that importance above what is given by managers. 8.2 by managers, experts say 8.5 for that. So, using this kind of the data which has come from this just for human factors, we can find out what is the perception gap, communication gap, understanding gap, and take measures to fill it. On work-related issues, the biggest thing which came is improper health, as felt by managers, but then effective equipment is what supervisors are told, workmen have also told, and experts are also saying. But this defective equipment, wear and tear, replacing it is the responsibility of the managers. They are not giving too much importance to it. And why it is not happening is evident from this code. They are not seeing it as important. That is why we are not rectifying this in practice. So in this case also, we saw gaps of understanding, prioritizing, which have resulted in a condition where more accidents could happen. Working environment related issue, highest score for time of day and weather conditions. Non-isolation of system. These three are the top by the managers, of which supervisors and workmen agree that time of day, work at a different time of day, especially in the evenings and night. And during summer, during noon, peak summer afternoon, which times when they have to work for a longer hours, there is problem. In this case, there is agreement between, but then the cause is weather. So it's they say God controls, we can't do anything. But people can choose when to work. They cannot choose that there will be no noon today or no night today. But then how much of work they do and with how much precaution they do can be in control. And you know, people dealing with electricity get most work just after a storm or during bad weather. During very good weather, they have very little work because nothing goes wrong. So their work comes, especially in maintenance, distribution and supply maintenance personnel, they get more work during rain. And that is when they are exposed to these dangers and hazards. Non-isolation of system is also an issue. And that issue has been increasing because of interconnected systems. Earlier we had just one transformer supplying to a route and no interconnections. So when there is no interconnection, you just switch off this and the whole thing is isolated. Now, you even have rooftop solar systems in houses, which are grid-fed rooftop solar generating systems on the rooftop, which push the generated power into the grid or the line. They have in the transformer, in the system which is there, to push it, there is an automatic control which is supposed to work. If the grid is switched off, then this system should not push the generated electricity into the grid. That safety system is there, but all these are devices. If they fail, what happens is still there will be feeding into the grid. And so proper isolation might not occur. So as technology progresses, there are more problems coming with regards to isolation. And work culture in the organization, see, even the supervisors agree that there is poor supervision. 8.1 they have given to supervision, lack of supervision. And the workers also have given the highest scores is inadequate information. That is, by the workers, inadequate information, poor documentation and reporting, also a subset of or a collaborator of inadequate information. So workers feel having problems with lack of information. So training and providing information is a method to improve things here. Lack of good system knowledge and standard operating procedure. Managers say that is there, but supervisors and workers don't feel that is there. This is a problem. Managers themselves are saying SOP is not there. They are supposed to make that SOP and give it. And they themselves said that SOP is the lack of that is the culprit. But both supervisors and workers don't feel that. Meaning what? They have found out a procedure of doing and they feel that is the best procedure or good procedure. They are confident of the procedures they are following which are not standardized. And that is an issue. Experts also tend to agree with the managers in this case. So here, though this data appears to be very trivial, there is a lot to be read out of that, understood out of that, and used. When we looked at an intergroup analysis, we found that workmen tend to underweigh the importance of human factors because it is human factors related mostly to them and the supervisor, not human factor related to the manager sitting in the office. The workmen themselves tend to underweigh the importance of human factors. The supervisors view most of the causes at slightly lower importance level than workmen and managers. So just after the worker comes the supervisor, and intervention, directions, and supervision after PPE and other things. It is the next thing which can, at the proximity of the accident site, which can change the scenario and prevent accidents. But the supervisors are just taking everything at a lower level. They see, oh, not much. They're not giving as much importance to most of the factors as given by workmen or managers. Though they can control most of the things that they have, which ultimately lead to the nasties which lead to the accident. Human factors are perceived to contribute maximum to electrical accidents. This is by taking the total of the points for each slice, followed by work culture of the organization. Work-related issues and working environment system have lower perceived contributions to electrical accidents. So the recommendations to improve the system are like this. It's a two-pronged strategy. First part addressing the work culture of organizations, and the second part addressing the human factors for effective reduction of electrical accidents. Looking by the triangle where the efficiency of interventions, as you go up or sure, interventions at the bottom will contribute more. That is why we are suggesting like this. Efforts to plug the holes in the cheese, work culture of organization. First plug the holes or reduce it for factors which have high scores and go on to lower scores factors. Working environment and work-related issues. Because many a times it is seen that work culture in an organization, when you start to plug, or if you have to plug, you have to do things at the other levels also. Working environment and system and work-related issues also. The lack of knowledge, lack of SOP, and things like that are very evident from the data collected. So effective training of workplace practices, safe knowledge, and closer supervision also. Closer supervision definitely will go a long way to plug holes in the CEA's model on human factors. Work culture of an organization contributes more for electrical accidents compared to working environment and systems. After doing PPE, the electricity board and distributions are concentrating on working environment and systems and are not working on work culture of the organization. But our study shows that work culture is more important. So, enough focus has to be given on that. So first, issues related to, because poor supervision is a part of culture, because it is seen across the people who have been. We did not ask just one. We did not analyze one or two accidents. We have asked so many people. And across that group of people, there is a certain behavior style. If that happens, it is an issue of organizational culture rather than the individual. So, at the highest level, interventions have to take place to try to influence the culture, change the culture, and make it safer. Working on live wire in some places, I've seen it is a practice. Supervisor also says that place to switch off is so far off. I don't have a bike or something. I can't walk that much. You just have to connect this, no? Just do it. So these kind of things have to be checked and controlled. Second issue is associated with the working environment and system and has to be taken care of. This includes electric fire or arcing. If a work, a line will not be charged if there is arcing, if that is made. Arcing has been accepted if it is electricity and if you are using naked aluminum wires and intertwining them, there will be arcing is what has been taken for granted. So these kind of things have to be, and working during thunderstorms and bad weather, because depending on, India is a country where we removed one king and now we have so many kings. So these kings or VIPs, if near their house during a thunderstorm also power goes, the poor people who are involved in distributing the power have to, in the rain of thunder, they have to go and rectify it. So these are the things that from practice, through use of model, through collection of data, rather than through perception, say things, make comments, it could be brought out. You could see from a simple study also, a lot of insights could be drawn. It's time for discussions and questions. I'm open for that.
Mom?
Ma'am, are you there?
Take over. All right.
Oh, ma'am, are you there?
Kavika, Ashish, anybody take over?
Yes. Thank you.
Yes, so thank you.
Thank you. Achha, take Ashish da, carry.
Yes. Thank you, Professor Vasi, for this wonderful lecture. we have many queries in the chat box. So I'll take one by one. So
Yeah,
the first
please.
query is, can you please explain the triangle shown on the right side of Henry's triangle model?
Okay, for that I'll have to just. Shall I share the thing or to speak?
Yes, you can share. You can share.
Okay.
No, you can speak, Professor.
Yes.
Because many people, the person who asked the question will have in his mind the triangle, but others might have lost the triangle. So I will just take it to the triangle. This one, no? This is the one to, this is the only one where there is a right and a left. So the right one is, these are not related. These are two things related to safety. This is the traditional accident representation in triangle. This is the injury prevention pyramid, which is from another case where the person had to do manual heavy lifting job continuously, cyclical job. And in that case, in a triangular form, they represented the issues that contribute to accidents. So overloading or making the person do too much work was the biggest. And strength training, weightlifting training even was the cause, which was not giving the strength training was the cause. Movements, making jerky movements, also awkward movement, flexibility, and so on. They put the causes in form of a triangle. And they called it the injury prevention pyramid. That is what is used here.
Yes, sir. Thank you. Thank you, sir. So our next question is, emotional stress and negligence have scored very high, nearly 9. Is that an indication for more behavioral issues?
Yes, it is an indication of behavioral issues. And also, it is an indication of, because usually it is not just one person who goes and does the work. There is a team, at least 2 people. Electrical work, single person doesn't go. So, it is work allotment issue also. Because this emotional alcoholism also, if the person is drunk, people who are allotting work, people who are accompanying know this. Emotional also, these issues are, so some work allocation issues are also involved. There is counseling and other methods, but that is not in direct control of the supervisor or the engineer. It is in the control of the person who is suffering and family and others, not as much as in the organization. But then, keeping the person a little away from this kind of work is an option that could be exercised. Not all work, but very, because work can be classified into less risky, medium risky, and more risky. So from the more risky part, if they can be kept away or they will be doing it, lesser number of those jobs, some amount of accident reduction can take place. Sensitizing on that in that manner. That is what there's no very proper solution there. Because when humans and emotions are involved, there is no quick fix applied to all solutions.
Yes, sir. Thank you for this nice explanation. And the next question is, what is the difference between work culture and human factors?
See, we say this behavior culture is a sigma of behavior. I would say not a sigma really, it's an average of behavior in an organization. It's an average of behavior in an organization. So, like I said, if all the supervisors tend to, in an organization, tend to give lower points to certain factors, then among the supervisors, there is a feeling that this is all there, we can't do much about it. So they have all accepted and they are not seeing the cause in the magnitude they should see, let alone act on it. So that's a cultural issue. The human issue is that single individual. It happens in some individuals, at the same time it doesn't happen in many other individuals. Then there is an individual issue. For example, alcoholism. If it is happening across the organization, all workers are alcoholic, much above the percentage found in the general society, then it is a cultural issue, organization culture issue. If it is at average level, as in find the society outside, then it is not an organization issue, it is an individual issue. That is how I differentiate.
Yes, sir. Thank you. Thank you, sir. So our next question is, can the lack of emergency arrangement to mitigate the effects of accidents be considered as a whole in the Swiss cheese model?
See, that is post-accident or incident. And in this study, I have not gone into that part. Am I clear? I have gone up to what causes accident. That is all in this model, in this analysis. Pre-accident. Post-accident, I have not examined in this model.
Okay, sir.
That's right. Whether emergency vehicles, what is the arrangement, those things I have not taken because post-accident I have not examined in this model.
Yes, sir. So our last question for today's session: whom survey report should be given the most importance? Its manager or supervisor or workmen or experts?
Here, see, the Swiss cheese model says that in the last cheese is always nearest to the accident. In the last cheese, if there is no hole, then an accident will not happen. Even if there are holes in the preceding cheese, if in the last cheese, if there is no hole, accident will not happen, theoretically. So, if you can plug hole in the last cheese, which is the human and the supervisor, and the site where accident is happening, then, like in the efficiency triangle you saw, most of the accidents can be curtailed. But then to plug this hole of culture-related issues, for example, in that organization, there is a culture that people will climb the concrete pole and work on live boys. That's a culture there. Almost a person who does not do it is teased as you are not brave. If that is the culture, then this last unsafe practice cannot by the human person cannot be done without changing the culture. So there are interrelations. But if you can somehow do that at the last cheese, you will get best effects.
Yes, sir. Thank you, sir. So thank you for answering the questions of the participants. Now I would like to invite Professor Krishna for formally providing vote of thanks to our expert speaker. Thank you, sir.
Before I speak, I request any participant directly want to ask any question to Professor Basi. You have an opportunity to ask one or two questions.
Yes, participants are allowed to unmute themselves.
Unmute all the participants.
Good evening, Professor Basi. It's well explained. Thank you very much. It was a wonderful experience for me.
Thank you, sir.
You said that human factors is the sigma, of work culture. Thank you very much. I'm a BBS fan and I love that quote. The only thing I still didn't understand is that right-hand side of your triangle. That was my question. It was only for the load lifting or the manual weight, or for every activity we can drop that.
Yes, you can. You can. If you can find the things that cause the accident, because here was an injury prevention triangle.
Yeah.
So similarly, for the case that you have taken, if you can identify and get hierarchy of causes,
okay,
you can depict it as a triangle and explain it. That the bottlenecks, if you do control, then so much will be reduced. Next, pay attention to the top one at the last, because its effect on the prevention will be least.
Yeah, thank you very much. And you said that the last cheese, if it is not broken, then the accident will not happen.
Theoretically.
Not with the overweight of all the other cheeses that will make the.
No. See, this is not the Henrich model of Dominus.
Yeah, I agreed.
Since if the hole is not there in the last cheese, theoretically, then even if this passes through the hole in first, second, third, it cannot pass through the hole in the last and will not come and cause an accident. For example, ultra cautious worker is there.
Yes.
Then nothing will happen.
Yes.
Another worker in the same environment
Yes.
will have an accident or incident.
Right. Mostly 60 to 70% of the accidents normally go to the level of the people of workers and supervisors.
Yeah.
Thank you, Professor Basi. Thanks a lot, and thanks a lot, Krishna sir, for allowing this thing to happen. God bless you, sir.
Thank you. Anybody else?
Yeah, Professor Girish Yadav, I want to ask some question.
Yeah.
So my question is
good.
for the human factor and the work culture, we have done a very thorough survey and prepared this, identified the causes. My question is whether you have taken it further for a risk analysis perspective, cost perspective, how much loss, probable losses is coming to identify for the management or bring info front of the management at how to how it is important to address it from a business perspective, to make it a business case study basically.
This much data itself, especially when you talk about accidents, then people don't want to talk about it in organizations. What will you come out with? Will it be very shameful for our organization? They are worried about. So, but I got so many people to participate and to get this. We made a presentation to the board. Yes, presentation, and asked them, because this whole thing was done without any funding, and collection of more data, putting people there will involve some funding. So we have given them a project proposal to get some funding to take it in deeper, so that actual action items at different places can be more specifically identified and help could be provided. But I'm waiting for them to act on it.
Okay, gentlemen, anybody more?
Hello.
Yeah, last question.
I would like to ask how to measure the culture of any organization.
See, culture consists of different factors, and with different perspectives measuring culture, there are instruments, survey instruments, standardized instruments available with which you can. But for measuring culture, which is required for safety, I have not seen accepted instrument which is there and is used widely for measuring safety. Because, for example, culture for arts and enjoying arts and culture, that culture study, examining the culture of a society, organization will be different. So the safety, looking at culture through a safety window. I have seen a standardized questionnaire for measuring safety culture. You need to work on it. It's a good topic to work on.
Okay. Thank you, participants, for putting very good questions to the speaker.
Thank you.
Who is there? Some lady's voice I'm hearing.
Please share the video.
Gundu sir.
Ashish, please mute all the people except the speaker.
Yes, sir. Now it is okay.
Dr. Basi, very interesting lecture. From the questions which people have put, I could see the interest, and I could see the way they have understood the Swiss cheese model. They have really understood. Of course, you have done up to finding out the causes and finding out what is the thickness of each, importance of each cause. You have taken up that much. Somebody is asked about, we want to know the effect, consequence. They can make the Swiss cheese model again for the consequence also. You told about causes, but very, very, very well explained, very clearly explained. So we here at CoE, we look at the Swiss cheese model as interventions or causes. What are the weakness parameters? What is the effectiveness parameters? From that weakness and effective parameters, we get the big data and start analyzing putting the. This is what Professor Maithi's specialization, which I'm very happy. You are core electrical engineer, Professor Bhasi?
No, I'm not. I'm a production engineer.
Oh, production engineer. Okay. Nice. You speak safety subjects there? No.
No, I don't, because I'm in a management school. I have to, my students, operations, systems, logistics, supply chain, those are the things which I have. Quality management, that is what I get to teach. Safety, I have not taught safety.
Oh, you're spoken like a safety expert. So thank you very much. Thank you very much for your spending time, for clearing doubts of all the people.
This was great, sir. Your arrangements are great and the audience is great. And that's the best thing for any speaker.
And I thank all the audience, participants. You made this session very lively. That's very, very interesting. And though the connectivity is a little bad today, but it is the message has gone through the people because the slides are so clear, so well explained, so people could grasp the content which you want to show from the slides very well. Thank you very much. And I'm also thankful to Mom. I know that you are not able to connect up, otherwise you would have put 2-3 questions definitely on this. But somehow the system has made you muted. I can't do anything, Mom. And other people who are conducting, Savik and Ashish, thank you very much. Professor Maiti, you want to say anything?
No, I only congratulate the speaker as well as I give my heartfelt thanks to Professor Bhashi.
Thank you, sir.
You have given a different ways of looking into the Swiss cheese model, from the learning from that means what I can say, from the horses, that means from the operators to the management, and then linking the holes. It's a wonderful experience to me also. Thank you, Professor Bhashi.
Thank you.
Okay, participant, thank you very much. Next week we'll have industry expert speaking on behavioral based safety, process safety. Mr. Narasimham will be speaking. That will be again very, very, very renowned and experienced person in the field of process safety. So thank you. Thank you all. We'll see again next Friday at 8 p.m. Thank you very much.